If you build AI, you've wanted a coding assistant next to you. But there's a catch a lot of us hit. Your model can't leave the building. The weights are proprietary. The data's regulated. The whole thing is internal IP. The moment an assistant ships your source to someone else's servers, it's off the table. That's exactly the problem we built AccelOne to solve. An AI development assistant from Brane-Technologies that runs entirely on your own machine. Model inference source. All local, nothing leaves. And the model doing the work is deliberately modest. A 35 billion parameter mixture of experts, only about 3 billion of them active on any given token, running on a single desktop GPU. Hold that thought, because what it's about to do goes well beyond what a model this small is supposed to handle. It takes one neural network and helps you run its heavy layer on whatever hardware you ship on. A GPU, a Kalray MPPA, an FPGA, and it checks the numbers on every one. Let's watch it take a real network across all of them without a byte leaving this box. Is a small trained CNN, a digit classifier. Its forward pass is 3 steps, a fixed convolution and pooling, then 2 dense layers. The middle one, Gemi ReLU, takes 784 features to 32, a matrix multiply followed by a ReLU. That's the universal AI kernel, a Gemi. It's where the compute is, and it's exactly what you'd push onto an accelerator. The 3 kernels are written once, in one header. The surrounding harness, load the weights, run the convolution, print the class scores, is identical on every target. To port to a new accelerator, only Gem ReLU moves, and the numbers must match the Python reference exactly. First, it inspects the machine with the real toolchain probes, not guesses. CPU, the AMD GPU, a Kalray Coolidge mini-core, and an FPGA path. It builds and runs the baseline, then proves the output correct, deterministically against the gold reference. 100 logit values, bit exact. That verify step is how we'll trust every port that follows. The GPU port's already in, same kernel, and it verifies too. CPU and GPU, one source, both proven. Now the accelerators the cloud assistants have never heard of. Here's the real test for the model. It was never trained on Kalray. A model this size has essentially no Kalray in it, no MPPA, no Coolidge, none of this vendor's toolchain. So it can't recite the answer from memory, it has to learn it, the way an engineer would. We show it the harness that's already there, and hand it one working Kalray example. And from that, it writes the offload in OpenCL, driving the vendor's C++ wrapper header, not from training, adapted, live, from a single reference. It writes the kernel, one work item per output neuron, then the offload that runs it on the Coolidge, adapting the wrapper. The harness never changes, only the one layer moved. Now watch it actually run. It launches the layer on an emulated Kalray Coolidge, 5 compute cores, and the network classifies all 10 test digits live on the accelerator, 10 out of 10. And the proof it's not just plausible, but exact. It checks 100 logit values against the Python reference, bit for bit. The AI took your dense layer to a many-core accelerator on your machine and proved it correct. For the FPGA, it switches languages entirely into C ground, Neosyn's hardware dataflow language. Again, nothing it was trained on. It pulls a dot product example and works from that. The fixed point multiply accumulate at the It writes the tile, 8 fixed point multiply accumulates, a bias, a ReLU, checks it, and simulates. 5.0, exactly what the math says. Then the part that still feels like magic, turning a neural network layer into actual digital hardware. Designing gates from scratch is not something a small mixture of experts model is supposed to be able to do. At this size, that's normally out of reach. But paired with Neosyn CG, it gets there. It synthesizes verdict real, actual gates, a multiply accumulate tree, and a ReLU, 52,000 cells, and it writes out the Verilog, your neural network layer turned into hardware by a local assistant on your own desk. That's AccelOne, the coding assistant for the AI you can't send to the cloud, that also takes you across CPU, GPU, Kalray, and FPGA from one network.